Hey everyone, Meteorologist Tuttle here with you, and we've got some storms that continue to kind of bubble up out there. I've been watching them behind the scenes, and looks like we're going to have one that may try to produce a tornado. I've been watching here for a while. It's not again the greatest conditions for one, but I can't rule one or two out here with this event. So we're going to go ahead and cover that and see how that goes. So thanks for joining me. Let's see. What we're going to do is just kind of flip around to different sources. You guys can follow me on, Adam's already saying, no trails today, please. You can follow me on YouTube, Twitter, Periscope, and Facebook, and all those are in 1080p, so you can pipe this up to your big screen television, and then we can go from there. All right, so let's get on with it, shall we? Let's take a look at what's happening. So out there currently, you can see how we've got quite a cloud deck out there. This is the leading edge of the cold front, just looking north of my area. And you can see how we've got those storms that are out there to deal with. They're going to continue to kind of develop along that boundary. And some of these are going to get a little carried away. We've already had some that are producing some hail, pretty good size, well over golf balls. Some of the wording in there prior was hail size up around 3 inches in diameter. However, when you look at the dual pole products, it doesn't indicate that. It indicates melting hail, which can be a false indicator of 3 inches. So we'll take a look at that too. Regardless, though, there will be some decent sized hail out there. It just may not be quite that big, but we'll talk about that in the threat for tornadoes. But regardless, let me do a quick round the world tour here. If you look out to the east, look up, got more storms, more clouds all the way down to the south. So there's just clouds all around the metro, and of course storms all around the metro. I'll keep an eye on this one up here. It's northwest of town, and we'll see if that does anything as it comes into view. All right, let's take a look here. Turn that off. Let's see, where are we? Okay. So this was the storm that had kind of an interesting look to it at one point. A little bit of a wall cloud-ish. Basically what it was is a really big lowering, like a scud decks where the updraft is of the storm. But there was never any like rotation with it. In other words, it was just kind of sitting there. It's kind of barely moving. That's not typically a tornado type situation. You usually have to see a rotating wall cloud of a pretty good speed, and then you'll get the tornado. So that didn't quite happen, although the radar started to look a little bit more favorable trying to go that direction. So I didn't cut in because I didn't see it happening yet. And even then, the last few minutes, it's kind of fallen apart from what I was looking at earlier. But we'll keep an eye on that one. So since we're talking about the potential for tornadoes, I'll go ahead and just kind of cover everything. Keep an eye on what the Weather Service is saying and all that kind of stuff. All right, so I'm going to flip through a bunch of different radar products and show you a lot of different things out there. So this is the big picture of Oklahoma. There's a severe thunderstorm watch in effect. That's what this blue area is you see on the map. Goes all the way down here to Lawton, Wichita Falls, and up here in the far southeastern Kansas. Does include Tulsa and Oklahoma City. Now, as we talked about last night in our Facebook Live, most of the action currently here is in central Oklahoma, where it will be through about, so we'll call it 7 to 8 o'clock. And then it'll move out of our area, then continue to press into eastern Oklahoma. Now up here in the north, they've had some pretty good hail out of some of these storms we mentioned. So the latest algorithms here is indicating hail size up to about 2 inches in diameter, and that is what's been reported from storm spotters. So that's called hen egg size hail, so it's a little bit bigger than golf balls. The algorithm are predicting hail size maybe as high as 2.5 inches. This is up around Tryon, south of Perkins, north of Kearney, and southwest of Cushing. So this is right along, just north of 105, right along 177. So that's where that particular hailstorm is. No threat for a tornado with that one. Might get some small hail out of this one west of Kearney. Non-severe really, just some heavy rainfall with that one. Back out here to the north and west, that's one we looked at on the camera view here a moment ago. Not really doing a whole lot right now. It's got some very small hail with it. It's a thunderstorm. It's going to have a little lightning with it likely at some point here soon. And it's kind of right along the front too. If you see this little boundary right here, this little fine line. So that little fine line is cold front boundary. Now, if this storm can stay anchored on this front, which it hasn't yet, but if it could get anchored on the front, then that could produce a tornado. It'll use the vorticity, the spinning motion along that frontal boundary to do it. So that's something to keep in mind. And So we'll kind of watch a couple of those that get closer to those boundaries. Back here on the west side of town, Union City, good little thunderstorm here. It's got some hail in there, potentially up to 2 inches. Just some thunderstorm activity from Binger to north of Gracemont to Minko. Nothing special about that one. South Oklahoma City, Valley Brook, Mustang, some heavy thunderstorm activity moving through. Otherwise, nothing too serious. The one down here on Newcastle was the one that had the larger hail reports with it prior, as far as the what the algorithms were saying in the radar data. Let's see here. Anything else? That's it. So those are the main areas of storm. So each of these have a severe thunderstorm warning with them. Generally, you're going to expect some potentially damaging winds, some large hail, and then on this particular case down here south, we'll watch for potential tornadic development for that one, and the one up around anything that may anchor around the front, we'll watch for that too. All right, so now what I'm going to do is go back to different radar sources and look in the details of this stuff. So when people report a weakly rotating wall cloud, that just does not get my attention. When they say, rapidly rotating wall cloud, that's when it should get your attention and my attention. But right now, weekly does not usually do much. But it's just something to watch at this point, but nothing to fear at this moment. All right, so this is the closest radar view. By the way, I'm going to show you the wind field. This is why we can potentially see tornadoes today. All right, so this is the bad wind profile from the radar, right? Now, for August, this isn't bad. We're August 31st. This looks more like we'll call it late May profile, early June, where the wind shear starts to die down. We can still get some pretty good, differential change in the direction. So you have a southeast wind here about 20 knots at surface base up to about 1,000, 2,000 feet. That starts to transition over to a southwest wind once you get up to around 5,000, 6,000 feet, and then a west wind. So actually, as far as the turning, ideal. Wind speeds are a little weak. They're around 20 knots. But this is summer. Things a little bit different in the summer. But that is why a tornado is potentially on the table here for today, because the wind shear does support that. We just kind of have to get a storm to get in the right environment, not to be impeded by other storms, that kind of deal. So it's not easy to get a tornado. It never is. Just even you can have all the ingredients there all the time and still nothing happen. But that's why we're here watching it for you. So these little circles just popped up. This little pink fuchsia you see on the map says probability of a tornado is about 10% at this point in time, which has gone up from 0, I think, before. So in other words, the indices. This is experimental product, by the way. Think of it as a preliminary AI, artificial intelligence, where we throw in a bunch of historical references into an algorithm, and then the computer then tries to gauge probability of a tornado based off of all those indices. And so it's starting to say, hey, at least there's a small chance. It's not a big one. And I've seen, I've seen this enough to take it with a grain of salt. But I think with time it'll get better. I think this is in the second year that's been implemented, at least used in practice here. So I loaded on here because I want to see how well it does. All right, so I'm looking for potential circulation centers. Let's see, what time is that? 52 after? All right, what time was this one? 7 minutes after. Rotation is tightening with rapidly rising scud, beginning to become rain wrapped. All right, so that was the last visual. So in other words, you won't be able to see this anymore. It's been obscured by rainfall. So the storm spotters, unless they're right underneath the thing, are going to have a hard time seeing with their own eyes what's happening. But what we're watching for is this little area right in here. So this is the weak broad circulation. Now, this is the radar system. This is the radar system right here, and we're looking here. So we're literally 2-3 miles from it. So if it were going to produce a tornado, this radar system is so close, it'd be easy to spot. And these broadness, which is about a 2-mile range of winds, would get extremely tight within a 1 mile or less area, and you start to see an increase in the wind speeds. So that's how we know that a tornado would be occurring, but that's not happening. All right, let's we're gonna bounce around. I'll try to guide you in my madness as to where we're heading. I gotta see, the big picture, which can sometimes be a little cloudy. And I split the screen for both reflectivity and velocity because as a radar meteorologist, I gotta see both. Sometimes I'll do just the reflectivity pattern, which is what you're used to seeing like on television. Those guys will show you the reflectivity all the time because it's easier, it takes up the whole screen, and they'll flip to a velocity picture usually once the tornado's already happened. Then they'll try to track it that way. I like to predict the tornadoes before they happen, so I like to see the velocity first so I can see it in my head and then visualize what's happening outside. All right, so let me look here. The hail with this 1.25 inches. Let me go back a bit. Let's see how far back I can go. Okay, so I'm going to take it back to where there was the warning criteria mentioned possibly 3-inch hailstones. Let's see, was it this one? Since we're waiting to see if the other one does anything. 2 inches there. I swear there was a 3-inch at some point. So we'll go with this one for now, Bridge Creek. Let me see something. Okay, so that was pretty good. And that was pretty good. Alright, so in this particular case, there was some good sized hail. It's not the one I was trying to find earlier that had the 3-incher. This just says 2-inch. So 2-inch I'll buy. So I look at these different products. In other words, this is the ZDR values, which go down low. They're in the gray. When I go to cost correlation coefficient, they're in this green area, which indicates values around the mid-80s, 0.86. So that's definitely an indicator of some 2-inch size diameter hail. Plus, we have the missing data here on KDP, which missing data occurs whenever you have large hail greater than about 2 inches in diameter. So in this particular case, there was some 2-inch size hailstones, more than likely, following north of Bridge Creek. And that was about 30 minutes ago. So again, things have changed since then. Storm's gone through many different evolutions. And then now we're kind of tracking around the Newcastle area and then heading up toward the south side of Moore and then in between there and Mormon. So it's going to split the towns in between. All right. So I'll come back to this since that's really the reason why I even got on. I typically just cover tornadoes or some damaging winds. Matter of fact, estimated wind gust out of number 57 is 72 miles per hour. So that's pretty decent with hail up to about 2 inches in diameter. S7. Where's S7? That's this one. That's the one in El Reno. Alright, so this one, El Reno, the radar is saying it's got hail size about 2 inches in diameter. It's also predicting winds of about 72 miles per hour at the surface as far as like a damaging wind gust is concerned, what the algorithms do. Believe it or not, it actually has some rotation with it, but it's not something that I would say tornadic. It's just rotation, just as far as like the storm dynamics are rotating enough to produce some large hail. I'll take it as far as that. And if you remember, I showed you in the model data last night those little tracks, helicity tracks. This is an example of a helicity track, an example of where you have the mesocyclone kind of going overhead, and you get the hail that tracks along with that. And sometimes you can get a tornado that tracks along with that. All right. If I get quiet sometimes because I'm reading the National Weather Service comments. So just so you know how, when I operate all this, I'm watching all 3 TV stations at the same time for their live shots, helicopter shots, Weather Service in their chat room to see what's going on behind the scenes, what they're doing or thinking. My live camera, so I can always kind of see what's going out the window since I can't look outside the window. And then this situation over here is I've got radar algorithm trips, and then I've got 3 or 4 different radars I'll put up, and then we'll look at some other weather data online. So I'll do all of that in a big multitasking nightmare. So I can give you everything there possibly is to give you all at once. And my finger hurts after a while from all the clicking with the mouse. But anyway, so that's kind of how things go behind the scenes that you don't know about, you don't get to see. And the rest of it's all up here. So, all right, now let's see, the south side. Let's go back to the south side. So this little hot pink, Newcastle. That's winds 48 miles per hour. Let's see, are we on SRV? Yes, we are. Okay. Let me make sure that's updated. It is. Okay, so there we go. New data coming in. This little hot pink, 66 miles per hour here in Newcastle. All right, let me go pull that up on this bad boy so you can see a little better. Let's see if this radar will show it. And we'll probe it. So let me hit switch products. That's at 49. Here we go. All right, so this is Newcastle. So we're getting some pretty decent winds on the backside of this thunderstorm that's moving through the I-35 area between Norman and Moore. But on the back end, the winds are downbursting up to around 65, 68 miles per hour. So again, to give you an idea, when I said wind gusts up to around 60 or 70, but 72 earlier in that one storm, or 76 now for that storm near El Reno. So it kind of gives you an idea that damaging winds are potentially possible with these. Now remember, those winds can do as much damage as a small tornado. So keep that in mind. Also, if you are interested in getting closed captioning for these live broadcasts, that will be provided in real time on Facebook. YouTube doesn't provide it yet. I have to have more followers for that to sign up on YouTube. And since most of you sign up on Facebook, it's not going to give it to me. And of course, Twitter doesn't, Periscope doesn't do live closed captioning, but Facebook does. They started that this year, which is nice. And so that helps me out. So for those of you folks that are watching those other two platforms, if you have to mute it, or you got a baby in your hands that's sleeping, or you're in a meeting at work, or you know whatever it may be, and you can't have the volume up, jump to the Facebook page. Links on many areas of my webpage, aarontuttle.com, etc. Okay, let's see. Let's take a look. Okay, so again, I'm not excited about a tornado situation yet with this particular storm. Just some damaging winds. And this one out here in El Reno has got my attention as far as some damaging winds too, south of 40. I'll have to get more specific. We'll have to zoom in to some of these areas. Let's take a look at this. So the Tidwar, it's got winds of around 76 miles per hour here at Twisted Oak Road. So these batch of winds here are the worst at purple, the orange colored to the pink and fuchsia color. Again, those are all from 60 to 70. That's around MacArthur and 350th Street. This is going to be west of 62. So that is where the pocket of damaging winds is, just south of Newcastle. So that's about a 1, 2, 3, 4 mile swath south of Newcastle, about a mile west. That's where the strongest winds are from this system. What would have been the circulation for that little weak wall cloud action, that's all eroded. I'm not seeing anything new. The leftover's been cut off and trapped and died. It's this little spot here. So it's not doing much. It's surrounded in rain, and so that's usually going to kill it and cut it off. So something else would have to happen for this storm to try to get back to a tornado type producing structure, and it's got a ways to go. But right now it's changing over to a damaging wind structure. All right, let's go back here to El Reno. All right, this one's interesting as far as the structure goes on it for producing a wall cloud and possibly a funnel. It would be coming up right along 81 and road is that 10th Street, East Oklahoma City 10th Street, and Highway 81. That's 2 miles south of 40. So keep an eye on that. That's a likely wall cloud. Now the problem is it's probably not visually detectable because it's surrounded in rain. Let's see, where's the front? Where's my winds? I need another that's still south of the front. Okay. All right. So we'll see. Right now I'm thinking a rotating area with probably a wall cloud. May or may not have like a little finger funnel from time to time. It's pretty weak, so I'm not overly concerned yet. Oh, look at there. The algorithm's just tripped on it. Probability of hail, 81% or 83%. Yeah, we know that. Probability of a tornado, 1%. So it's just now detecting even that probability. There's one at 2%. So Weather Service put up a good problem here on the south side of town. Besides the wind threat here, the heavy rain event coming through Moore and Norman. So let's go look at that. So this Newcastle Blanchard. What do I want to do? Let's try this. All right. It's what it's been doing. It's nothing out of the ordinary. So all these little brighter colors you see on the right, that's a KDP, and that's a product that just tells us it's extremely heavy torrential rain. All right. So in other words, potential for some flash flooding is possible when you get heavy rainfall rates that exceed, an inch or two per hour. Sometimes they can go up to 3 inches per hour. Let me turn that down. Okay, let me see here. Anything else? Go back to this guy here. Turn that back over to where I want it. All right. It's got an interesting look to it. Okay, what about our guys up here to the north? I'm going way up here to Stillwater. Those kind of all broken apart. There's like a bunch of little mini thunderstorms. Let's see, this one, just some heavy rain. Looks like a little bit of small hail, inch in diameter. Okay, so these aren't anything to write home about at this point in time. This particular storm, Quay, Merrimack, and Hallett over the next 15 minutes, moving up to the northeast, kind of skipping past Yale and Jennings, north of Cushing. Although Cushing, you're getting the east side of it, but the main bulk of it, the hail, is going to go to your north. Let's see what else we got. It's back to that Cashin one. It's a mess. All right. The only two really of concern that I'm even going to spend any time on is the south side one, and for the damaging wind, and then this northwest side one. It's the only one that actually has somewhat of a mesocyclone with it at this time. So we'll see. Let's go to this guy, and I can show you another product. Let's see if this is working. You can do it. Or maybe you can't do it. Come on, you can do it. You're not going to do it, are you? Okay. You know what? We'll solve that problem. I'll just kill it. Stupid program. Alright. I need me some more memory. Yes, I don't know what happened to that thing. Alright. Let's see what else we got. Okay, so you guys here in Norman and Moore, got a heavy thunderstorm coming in. Still got some wind with this one. Newcastle's come down a little bit, about 60 miles per hour. There's our new little circles that come on. Probability of a tornado is 2%. It was 10%, 10 minutes ago? Now it's at 2%. So not overly excited about that. And I don't see any areas of circulation anyway. So it's not going to do that. Let's see. Hail size. You got a lot of these little 3/4 inch icons here. Let me see what the mesh shows. 1 inch at most, so the hail size has come down. So this storm has actually petered out. It's lost everything that it had going for it, and it's nothing but a rainmaker at this point. So now I'm already bored with it. But it will get some, I don't want to say bored with it, because that's still got some wind with it. It just doesn't have any significant large hail, and there's no tornado threat with it. So let me rephrase that. I want you to get angry with me, because there is still some good wind. So Newcastle southward, your trees are probably doing all this. So, all right, let's move on back up here to El Reno. See what's going on here. So the hail size of this one's pretty decent here on the western fringe of town. Let me put up a couple of these little deals here. Oh yeah, let's see, let's put that in the center. Okay, so this, let me smooth this. make it easier to see. All right, this gray area indicates large hail, and it's coincided with this little purple area here in pink. All right, and let me see. Let me get off of there. Get off. Okay. Now let me check the cross correlation coefficient, because that's actually a better indicator. Oh yeah, that was in the toilet. Oh yeah, that's a big hail there. So let me check one final thing. Yep, dropped its load. So some pretty decent hail fell, and still is some pretty decent hail falling in this area here, just west side of El Reno a minute ago, and now it's moved to the north. So this little hail core dropped most of its load as far as really big hail west of town. But now it's kind of, what's left of it is kind of shooting to the north of town, coming up on 81 and Curtis Street, and then Jones Road northwest. So that's where the big hail would be for this particular storm. Yeah, the algorithm hasn't even caught up to it, I think because maybe it was so small. I'm not sure why I'd missed it. But that was a little pocket of some nastiness. All right, so that's a hailstorm. Let's load this thing back up. Let's go back down here. The winds are still cranking with this one. I still got a lot of pink on the map. So again, that's about 50 to 65 miles per hour all in this little swath here. So that's some pretty good wind. Let me do a track with that. Okay. That may not do much. So hail probability about an inch, inch and a quarter. And then the whole storm is moving to the east. It's not very fast mover, so what you have is what you get. I think they're about 15 miles per hour, something like that. So they're not a overly strong system. And of course, a lot of these have plenty of lightning with them. So this thunderstorm warning, for example, goes until 6:15, moving east at 20. So it's picked up 5 miles per hour since last time I looked at this. Packing winds, it says the wind around 60. We obviously detected winds a little faster than that, higher than that, a little earlier. Okay, so that's the one there. And then this guy up here in El Reno. What track is it going to show? Anything? Piedmont. Of course, that's just from this back end where the hail is. Piedmont, you're going to get some rain just already coming in just from the northern fringe of this storm. All right. Okay. So despite that decent wind shear to work with, for a supercell type structure, the storms are having a really hard time getting to that point. So if you're new to Oklahoma and you're new to this whole fiasco of severe weather coverage and all that kind of stuff, at the bottom of the crawl, I give you a lot of tips on what to do for severe weather. So you'll be prepared, kind of what and how to stay prepared, kind of how to get your information. Yeah, so this is where I shift gears in a good old-fashioned Oklahoma thunderstorm. Even this one up here north of El Reno, the little rotation with it, that was pretty decent there for a while, pretty small and a lot tighter. Has since broadened out and weakened hugely, and the hail core with it has already dropped. Usually what that means is it's weakened dramatically. and so you kind of don't have a whole lot of, let's see, a whole lot of oomph left with it when it comes to either one of those things, wind or hail. Let's see, we continue to see redevelopment in the southwest flank of the storm across the South Metro near Cole and Goldsby. This will result in a continued hail threat and an increasing heavy rain and flooding threat downstream into the South Metro, Norman, and more. So that's the Weather Service discussing the storm here, which earlier I said it was moving at 15, and the algorithm told me no, it's 20. Well, I really don't see it moving much, so it's probably still 15. And still rain to beat the band. Let's see. Oh, I could have loaded that. Yeah, could go back and get that. Just thinking out loud. All right, back up here to the north. You guys up in Stillwater and Glencoe, just some thunderstorm activity, nothing big. Meridian, same kind of deal. So there was historically some hail sizes that approached 2 inches northwest of Tryon, and I think we talked about that a while back. So it's good to get these little hail reports in there. I'm surprised we didn't get any wind reports out of this storm, though, for the Newcastle area. I was really expecting to see at least something come in. By the way, when you see these helicopter shots and these live shots of these guys, the storm chasers, and they have this rising, motion. It's called scud, and scud happens all the time. Scud means absolutely nothing, just so you know. It just means that there's an updraft to the storm. Well, all storms have an updraft that wouldn't exist. Scud is just condensation. It's where the moisture is getting pulled up. And due to physical processes, it condensates and then kind of just lifts like a little baby cloud. And that happens all the time. And sometimes if scud gets really big, it can be misinterpreted for a tornado. So, for example, you're driving on the road and you see this huge, looks like a triangle thing reaching the ground. You go, that's a tornado. Well, it could just be a big thing of scud. So they're very, very common. Okay, so this particular storm is the south end around Cole is reorganizing. So this is where you'd watch for the new development of potential circulation feature to develop east of Cole. And this is the tail end of it here. So you would watch in this region here for the developing circulation. So if you look over here, there's some purple, which is range folded, which means it's just bad data. But here's the green leading into that. That's wind blowing toward the radar. And the blue and the red is wind tilting away. So there's your convergence axis. So this is how you start to get that developing low-level circulation. But this is just beginning stages. Will it do something? I don't know. We'll see. That's what we're going to watch it for, but nothing in the short term. It'll be a while. Let's see. So overall, this storm is rated as a 5% chance of producing a tornado. So Goldsby here, some pink on the map just north of you. Let's see, what road is this? Lamar, just west of 35 on Lamar. Got some winds up around 60 miles per hour. Little pocket there. The big winds that were earlier along 62 have since diminished and gone away. Okay. Let's see about these guys up here. No, I don't see anything. Let's go to this radar view. Take a look down here. Nothing. Too far away. Come up here to the north. Nothing. 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 So the difference when you watch my coverage, other than the fact you could probably go to sleep to it. Only I could put you to sleep when a tornado is coming. Is that it's very relaxed. It's very stress-free. You could grab a glass of wine, just sit back and chill and just hang out and just do a play-by-play. And this is kind of how I do it. It might be a little too low-key at times, but it's just it's a lot of analyzing the data and telling you what it's actually saying versus just what I call wish casting or fear casting or just saying outlandish stuff that has no basis in reality because it's TV and you gotta make it exciting. I detest all of that, just so you know. So I take the old science approach. All right. Okay, so this one down here, Goolsby, is regenerating the south end of it. We're going to see what happens with that. That's why I'm going to hang on for a little while longer. This guy here, this little tail, is what's feeding into it. So this will be the spot where you would look for potential low-level circulation to develop. And when that happens, it'll show up here on the velocity. It'll show up in that same area. So this is the same picture, just split, same storm. So that also means with this storm kind of redeveloping down here, it'll get a new core, and with the new core will come more hail. And with the new core, you usually get bigger hail. So you'll get some hail out of that for you guys pretty much right along Highway 9, south side of Norman. You'll be getting the hail out of this guy. Right now, hail size indicated on the radar scan says 2.75 inches. Now let's go take a look at that, see if that's reality. We'll go to the mesh product here on Highway 9, and the mesh does say 2.45 inches. All right, well, let's go verify and see if that's correct. So we're going to look at the dual pole products. This is ZDR. Not quite seeing it. I do see some spots possibly. Let's go to cross correlation. Nope, that's a bust. Let's go KDP. Nope, that's a bust. Okay, so if the storm does have 2.75 inch hail, it's not coming down the surface yet. It's a loft. So this is what I'm going to do. I'm going to go back to one panel, and we're going to split this thing in half, and I want to take a look at it. And we're going to see, I'll do a three-dimensional box, and then we'll do a cross-section, and we'll see where the hail is. Do you see it? This is it. So here is that big hail core the radar saw, 2.75 inches. But you notice this is in height. So this is 8,000 feet here. And so going all the way up to 35 to near 40,000 feet. And this is a shaded reflectivity value of 60 dBz. So all of this is large hail and hail that's over 2 inches in diameter. So there's your hail core that eventually, guess what's going to happen? It's going to come right down to Norman. So is that, because what goes up must come down, so that hail core will collapse. So you guys, again on the south side of Norman, be getting some of that hail. If I were to put this on here, these are all the other contoured reflectivity values, but I just like to make it easy by doing the ISO surface. And then I've got it registered at, 60. So if I take it down, or up I should say, to 65 dBz, still a pocket there. Whoa, that's big time. That's nastiness. Okay, so now let's kill that. And again, we're looking at this little spot right here. So let's get right along Highway 9 and 35. So this is where the upper level hail core is. That'll be coming down. Let's do a cross section. See what that looks like. So a lot of this is what I do, like what you're seeing me do right now. This is what I do when I analyze severe storm cases for like engineering firms, law firms, places that file insurance claims. So I do a lot of this analysis to find out, if they got hail, how big the hail was, that kind of deal. So the Weather Service is going to go ahead and issue wording to include 2-inch size hail on the storm coming into Norman. So those guys can also see this three-dimensional stuff. They got all the tools there too. So they're doing the same thing I'm doing. So the TV guys won't do any of this because they're on that one-dimensional plane, and then they'll do a lot of the storm tracker stuff. At least the guy on the wall. If they have a guy in the weather center, he might be doing this. This depends. There's a lot of stuff you got to do behind the scenes. So let's see here. Let's take a look. Let's see. We'll go to the cross correlation. That's a hole there. That's a definitely okay. So what I was looking at is in this area here, you obviously want your CC values to be low for the hail size estimations. And when you get into the green for this, we're down into like the 0.7, which indicates some hail greater than 2 inches in diameter. So that's kind of why I was looking at that. So anyway, just something to look at. So Weather Service, Vivek, he's actually my intern. When I was at Channel 5, he was our intern at Channel 5, and then that was so long ago, man. That was a whole nother lifetime for me. And he moved on and went to the Weather Service. He was out of school at Norman, and he just typed out that the storm is the most intense with 60 dBz at 35,000 feet. And I'm like, yeah, we just took a look at that. So, see, told you he's doing the exact same thing that I was doing. Great minds think alike. But that's how they do it. Just so you know, kind of what I gave you is how those warnings are issued. They look up aloft, and then they see what the algorithms do, and they go investigate them. Then they look at some of the parameters, and then they put the wording out in the warnings, that specific wording, 2-inch size hail or 3-inch size hail, based off of all the training that we've had and what all the studies and research have shown for correlation. It's pretty neat. Radar meteorology has come a long ways in the last 20 years. I mean, light years. And seems like every few years we get more and more. Hold on, something caught my eye over here. Okay, let's do this. Remember I was talking about Scud? Let's see what this is. So if you were from a distance, you go like, hey man, it looks like a tornado. Look at that thing coming down, right? Let's go take a look. I mean, it looks pretty ominous, doesn't it? All right, so where am I looking? I'm looking due north. That storm up there in Cashin. Okay, so that would be an example of some scud. That's like on the leading edge. It's low to the ground. It's kind of in a weird, funky configuration. And you go, man, is that a tornado? So the answer, of course, is no, but just an example. I'm just going to look at a different radar while we look at that. So this is my roof cam. So, stations have a tower cam. I've got a roof cam. So AT's weather cam. So I keep a close full eye up there on that stuff. Let's see. Where are we? Anyway, we've lost it, so I'm going to back out. Works great until you get the rain that ends up blocking your view, right? All right. it's clouds and rain as far as the eye can see. All right. We'll get off of that. Oh, you know what? I didn't even show it to you because I forgot to press the button. Oh, I'm such an idiot. Sorry about that. You're probably yelling at me on your keyboard. We can't see it. We can't see it. Oh, I forgot when I pressed the camera button, I got to press another button. See? Multitasking. That's too much. Anyway, you missed it. It was really great. Jeez. Oh. Come on, Aaron. You better next time. All right, let's get back to the radar. You stared at this the whole time anyway. God. All right, shake it off. Get back in the game, son. Okay, so down here in the south, Goolsby, some big winds still up here. South on Highway 9 and 35, so that's nothing new. Let me see about the hail. Let's get off of that one. Let's come down here. And we'll check the wind again. Oh, so the hail's starting to come down. This little hot pink zone. Oh, some of it just dropped. Let's see, did it all drop? No, just a little bit. That's right along the river and just north of 9. So it's kind of in a dead man zone here. Just literally right over the river, so there's no roadways. It's raining out there big time. Cats and dogs, it says in the weather station. 2.26 inches an hour. It's a lot of rain. Hey, we finally got a wind deal out here west, east of Newcastle, but west 35, and it says estimated 55 to 60, 4 miles southeast of Newcastle. And that's, let's see, what road is this on? Penn Avenue and southeast 32nd. So finally gets at least one wind report. That's from my National Weather Service employee. I'd like to have gotten the wind reports when it was south of Newcastle for radar verification, but we didn't get it. All right, let me split the screen again. Nothing. Oh, good grief. What are you circling over there? Okay, buddy. No comment. All right, let me go up here. So this Guthrie storm, that's riding along the cold front, and it's got a little stronger reflectivity value, so it's probably going to get some bigger hail with it. There's, 2.25 inch size diameter hail aloft. It's not, again, at the surface. We'd see those pink colors on the map, so it's just aloft above the surface. So you get some big hail in Guthrie, surrounding areas here pretty soon. Let's see. Let's just go back into that. So that's mainly going to be on the north side. So here's some coming down. It's north of town. So this is parallel on the river, North Road 3143, which is a little farm market road west of 35. And good grief, this where 74 C ends. So it's east of there, between there and 35, just east of 77. So that's that little spot of big hail coming down. Otherwise, Guthrie itself probably does have some hail, but it won't be that kind of size. So you guys lucked out on that deal. Go replay, yeah. Okay, you know what? Just for fun, let me go up there and look. Where'd it go? There it is. Okay. Yep, there's our 60 plus DBZ core hanging aloft. So you can see how it's just north of the city of Guthrie. So you guys lucked out. The big stuff will pass just to your north as it starts to drop north and east of you, just by a few miles. All right, we'll close that one. Okay. Let's go back down here and see what's shaking in this storm again, see if anything's changed. Okay, so this one's dropping its load, looks like. I'll go back in time to make sure, but I'm pretty sure. Yeah. Oh yeah, look at that. Okay, remember how we were tracking that big core? So there it was there, and then there it's starting to come down, and then there it's falling down. So a big chunk of it, and when it disappears like that from that, that's a lot of surface area that's gone. That means it's hit the ground, it's on the floor. And that is west of 35 and just north of 9. That's where that big chunk fell. So hopefully you guys are normal on the south side here. Once you get east of 35, hopefully the majority of this is dropped, before then, unless it kind of gets another core going up, just to save you from the really big hail. Okay, so this one's starting to get more of a classical supercell structure, and by that meaning, let's go, what do I want to do here? Try this guy. So it's got the hook echo like this. So that's the classic supercell type structure. However, this little wind here, this little reflectivity areas is air that's gusted out ahead of the storm. So if the mesocyclone updraft area is here, this stuff here has to get pulled in. This environmental air down here needs to get pulled into it, and this is blocking it. So this will have to erode a bit or get pulled in so that the rest of this can get pulled in. That's a very long explanation as to why it will not produce a tornado anytime soon. This has to change, but the overall structure has improved. So as it moves south and east of 35, we'll have to watch for that potential. Alright, there's still a mess up there. Glencoe, Pawnee. Just some heavy rain, a little bit of hail, lightning, probably some wind every now and then. Let's see, I don't see, there's a little bit of wind there, Logan County, north of Guthrie and west of Langston. Let's see, up there I don't see anything else. That's too crazy. The stuff here in pink that you see, this thing along 3170 and what side road is that? East Road 730. That pink area is about 50 miles an hour. The one here, it's about 55. That's north of 74 and east of 77. So not bad. Not anything like the ones down south that we had earlier. Those winds have since diminished a bit. Let's see what we got here. Is that a divergence signature? It sure is. Okay, so this one kind of had an interesting, not quite a microburst, more almost like a macroburst. So this is this green area here is winds flowing toward the radar system. This area of wind here is the winds blowing away from the radar system. So that puts the void here. So in other words, that's the storm when the downdraft comes down, it hits the ground and splits out like this. So one goes one way, one goes the other. So the radar beam detects the split difference, right? Well, in those times, that's where you get the 60 plus mile per hour winds that come down the surface at that split, and then they fan off from there, not as strong on each end, but right in the center of that downdraft. All right, so Weather Service did put up a green box, which stands for flooding. So let's see what that says. Let's see, flash flood warning for north central Cleveland County and central Oklahoma. Radar indicated storms producing 1 to 2 inches of rain have fallen. Ongoing flooding is expected to begin shortly. Up to another inch is possible. So we're talking about southern Oklahoma City, southwestern Norman, Moore, and Noble. This includes I-35 between mile marker 109 and 115. And here's the old expression that we always say, turn around, don't drown, when encountering flooded roads. Most flood deaths occur in vehicles. And of course, the excessive water flooding will fill up creeks and streams and urban areas, highways, streets, underpasses. So stay away from low-lying spots. So believe it or not, you have to take flooding seriously. It's the least sexy weather event of all. If you want to use that term, no one goes, ooh, look at all that flooding, but it's like, wow, look at that hail size, or wow, look at all that lightning, or wow, look at the tornado. And flooding just doesn't get the respect that it deserves. So it ends up killing more people, believe it or not, than the rest of them. So probability of tornadoes increased to 25% in the latest figures from the storm. There's that little hook echo getting better defined, but again, there's no inflow to it on the surface tilt. Let me go aloft. We'll look at some winds here. Yep. So we shall see what happens with that. No threat in the interim. Just getting better organized. Let's see here, up north. So this Guthrie storm will be finally hitting Stillwater. I think Stillwater, you got lucky. I think it kind of went all around you as far as some of those other storms. This one's going to clip the south end of you. Those other bigger storms kind of went around you. This one may actually come right at you, assuming it holds together. The time on that, these little dots here, Coyle at 6:02, Stillwater 6:26, so in about 30 minutes. Glencoe after that, and it's got Langston also in there, of course, right now. So there you go. That's the latest look at that Guthrie storm. And it's still got a little bit of hail here on 35 and County Road 74. So that's where that hail is located. And it's got radar algorithms about 1 3/4 inches. That's golf ball size hail. So the hail size not as big as it was on the south side, but still pretty big. So the roofers get a little extra business here late summer. How about that? Going to have some hail damage in some of these homes. Okay. Let me see something here. Downdraft gust potential now is down to 59 to 60. So about 60 mile per hour winds, which is less than what it was, we were looking at wind speeds for the first part of this storm when it was collapsing. Let's see here. So the hail size with this still being detected east of Goldsby, up around 2 inches in diameter. It's some big hail. I was looking at this product for its probability of severe hails at 95%. And what else do I want to see? KDP. I don't know about that 2 inch. Let's try cross correlation. Now here there would be this little blue and green area. That's a better idea. Let me see if it's melting. Go back. Yeah, I think it's melting hail. So it's probably some big hail, but it's melting hail. That's why that value is a little higher. And the ZDR, but see, because the VDR is positive, it's a tough call. Could be a mixture of some big hailstones mixed in with some small ones. Anyway, splitting hairs. So some big hail, regardless of the exact size, northeast of Goldsby, where you would normally have it on a supercell thunderstorm. So I were to take this and draw my circle again, so this is the hook. This comes out to be the storm itself, like this. So your strongest, your biggest hail on a supercell thunderstorm, just so you know, is going to be kind of two areas. This area here, actually could kind of wrap back into the hook a little bit, but then the bigger hail area is then within this region here. That's a terrible color, you can't even see it. Let's go this guy here. So this shaded area here would be the biggest of the big. So that's kind of where we're looking at the hailstones there. So if we want to look at that, we can draw our little cross section and see how well it looks like. I don't think I picked a good one. Let's go back, try that again. We'll cut right through this side. Okay. So there you go. So there's the hook. So we're going to see what I'm talking about. So you've got the hook, the deal here. Let me try drawing that again. That did not go well. All right, there's your hook. There's your supercell coming in. Again, this will be the big hail core will be like this in this area, with the biggest kind of in this zone here. So let's take a look once I tilt this up. How come it isn't? There it goes. Whoa. All right, I'll have to clear that, but there it is. So you get the idea. So there's the biggest hail here. That'll come down at some point once it gets too big to be held aloft. And that's got some white values in it. Man, what is that white value? 70, 72, 73? Yeah, that's big. All right, let's go take a look at three-dimensional view. Now I got me curious. So if you ever want to know what do I do when I'm not broadcasting live and there's sometimes storms like this is what I do. I look at this stuff because it's just neat. All right, let me go back one. Yeah, so there's the big hail and it's coming down. See, it's on its way. So it won't be much longer, and some of that's going to come to the surface here on the southeast side of Norman on 77. And that's a 70 dBz, so that's 60 dBz core, wasn't it? Yeah, it was. Let's see. Oh, purple. You know, earlier in that other thing, we saw some red or some white. This is 65. So this, unfortunately, this three-dimensional views don't capture every time scale that the other flat view does. A flat view will update, I think it's every 2 minutes if it's in a certain mode, where this one has like usually 4-minute gaps, sometimes 5-minute gaps, so it misses the whole picture sometimes. So it's not always every 2 minutes, which would be great if it was. So I can see, I have to look at both to look at the whole picture. So there's some tree damage west of Riverwind Casino. Alright, so this thing's getting better organized. It should have a nice little wall cloud with it if you looked out the window. It's just, it's with this gust front here out ahead of it, it's just not gonna do anything yet. It would surprise me if it did. Like, big surprise. Take that off. So still windy down here. Goldsby, man, this bright pink is 67. So let's go to this guy so you can see it. What is this showing? 65, 61, 66, 67. So there you go. And that's just north side of Goldsby by about a mile and a half. Right between there and the river. So the river's a good place for it. Take a pause, see if there was anything important that came in on my phone. So I changed up the graphics a little bit on the broadcast. If you've noticed, I'm always tinkering with something. Can't leave well enough alone. So hopefully you like the change. If not, leave me a note in the comments section. Just go ahead. I can take it. If you don't like something, tell me. I'll change it. Let's see. Okay, so we're back here to this guy. Got some wind coming down near Noble in Cleveland County here on the east side of the river. Let's see, what road is that? Southeast 329th Street. That runs west out of Noble. And it kind of splits. There's a road that splits to Corvette. Corvette Road. I want one of those new Corvettes so bad. One day, before I'm dead, I would like to have one of those new Corvettes. I would like to have it before I'm too old to drive it to where I can't even see where I'm going. So somewhere between now and 15 years from now, 20 years from now would be nice. Alright, so let's go take a look at that data. So there's still the winds in Noble, and those are about 60. Let's see what this radar is showing. That does not look... Okay, there it is. So these winds here, that says 65. So between 60 and 65 here in that same area. TVS J6. Where's J6? Go take a look at J6. So my little algorithm over here will trip on cell identifications when it thinks there's something of interest. And it said a TVS for J6. Oh, that's for the one that we're on. So that's this guy here, this little pink deal. It says, see this number 4? That's a TVS icon. So the TVS icon just means tornado vortex signature. But before you get too excited, there's a lot of tornado vortex signatures. That doesn't necessarily mean anything. But it gives you some values here, max divergence and all this kind of stuff, where it's a precursor to pay attention. Okay. But it can get tripped in the noise, like in the false data sometimes too. So there's, so you'll notice those like on my weather app, AT's Weather to Go. If you have that, you'll get a TVS icon. So if you click on the storm, there's an arrow. To make sure you have your arrows turned on, it says NWS vectors. So you turn there's a little box in that for the arrow, right? So in the end of the box, not the end where the arrow is, the point of the arrow, but back where it starts, a little white box. You tap that, that'll open up a whole new window. In that window will tell you what kind of storm it is. The TVS, a meso, which means rotation, hail. And then it'll tell you what's in it, like how big the hail is, how fast it's moving, and then it'll have a little slider bar, and it'll give you your estimated time of arrival. So, really cool stuff. Matter of fact, I'll just show it to you. Actually, I need to pipe this into my graphic system, and that way you'll be able to see it. So if you don't have it, it's AT's Weather to Go, Apple and Google Play. You turn on my vectors, my lightning, the data. Okay, oh, so matter of fact, I have a TVS arrow on here right now. All right, so I will click the arrow. So all I did is I touched, okay, let me get that off of there. Okay, so first off, so there's what it looks like, right? Now, you see, I'm gonna touch the back end of this arrow in that rain, and then there you go. So now it's got TVS, and it tells you the movement, all that kind of stuff, right? And you think, oh, okay, that's cool. Well, I'm not done yet. It says severe hail 90%, size 3 inches. I'm going to touch that white box, and then look what happens. See this? All these little values that tell you all kinds of cool, nerdy stuff. And then on top of that, it's got your cities list and the time of arrival. So seriously, you don't even need the guys on TV. You got this, you're good to go. So that'll kind of give you anything you need to know when you're traveling, not only across Oklahoma, but just across the whole U.S. It works for everywhere you go. So take that with you, and that way you get some extra info. So that's kind of how that works. Some people, I understand it because you have to be really techie sometimes to get some of these more difficult apps. And the only way you do that is you start pressing things and see what happens. So just by touching stuff, sometimes you get lucky, like, oh, it's like an Easter egg, right? So that's an example that some people may not even know that's even there. But just so you know. Okay, where are we here? Let's see. So this structure, it's having a really hard time because it's still gusted out. Again, see this fine line right here? It's cutting off all the inflow to the where it needs to go. So that means the supercell's having a hard time maintaining any low-level structure circulation. It's got mid-level, no problem, but it's the low level it's not getting. It's not getting all that it needs. So hail size 2.5 inches in diameter. Right here in Noble. See if the winds were still up there. It's pretty good. All those little pink areas, those are all winds of 60. Okay, let's go back up here to the north. Ooh, look at that. Hadn't taken a gander up here in a while. And I come over here to Skidee, and there's a big old hail core in Skidee. 2.5 inches on the algorithm. Oof. Oh, look at all that black and white on the map. Oh, that's nasty. I feel sorry for you guys. You guys got pounded. That was Blackburn Skeeter Road. Goes east and west out of Skidee. And of course south from there, northeast of Pawnee. So you guys in Pawnee lucked out. Look, see how it was just on your east side, this hill core? And that was a big core to be dropping for that long a period of time. From there to there to there to there to there. That's a swath. That's it. I'm going to go look. Let me do something here. Hang on. I got to find something. Where am I looking? This one. Oh, I didn't mean to do that. Well, I'll do it anyway. Okay. Do this one. I can open up that other one later. Alright. Okay. Hail swath. Okay, so this is the hail swath that we just looked at. For 30 minutes. And so that goes through Pawnee 64. Up northeast over the river. Let's see, 2312. So let's go current time, auto update. Severe hail index off the chart. So let's show you the hail tracks in general over the last, let's go 4 hours. No, that didn't work. 6 hours? No. Okay, 2 hours. 24 hours. It worked there for a minute. All right, let me try 6 hours. Nope. Go back to 1 hour before. Nope. All right, we'll do 2. Oh, we're not going to work now at 2? Come on. You worked a minute ago. Don't be a punk. It's 30 minutes. Lame. All right. Well, I got the 1 hour track on there anyway. So these little bright areas you see here, Osage all the way back down. These are hail swaths. So when I tell you roofer's going to be happy, now you know why. Even all the way down here the south side of Oklahoma City and out toward El Reno. So if you're a roofer going, who got hit the hardest? Well, hope you're watching me, because I'm going to tell you, we're here in west of El Reno, southwest side of town, west on I-40. And then if you head down here toward Norman, from really Newcastle south and east all the way through Norman, down 35, that was the other big hail core area, hail swaths. So there you go, so far all over central Oklahoma. A lot of these are 1 inch to golf balls, and then you're going to find some pockets where it hit 2 inches or maybe a little higher. All right, so that was what I want to show you on this deal. All right, let me look at something else while I'm here. Did they ever turn that on? I don't think so. So the front has not moved really. It's still stuck, which it wasn't supposed to move anyway. So, but it's doing something like this. So that's why those storms kind of formed north and west of us. And then the ones that formed south of us formed along the outflow boundary from this morning's rain. That was another little leftover boundary of convergence that the storms fired on. And honestly, if that morning stuff hadn't left that little boundary, and all we had was the front to fire off, it'd have been a completely different outcome. The metro would have been just hammered. The storms would have been way stronger because we were getting a lot hotter. We would have hit 100 degrees. I don't know if we did or not, but we would have hit 100 for sure, across a larger area. And then the tornado threat, we'll have to see. I mean, it may have gotten up a little bit better with better Cape values. So, but that little morning round that kind of lingered and left that east-west boundary, that actually kind of saved us from the magnitude of severe weather today. So, just so you know. Here is a look at satellite view. You see how these things just blew up here over central Oklahoma. And you can even see the front right here in the cloud cover, cloud cover satellite. This is visible. And then the east-west boundary was right here this morning, so watch it right there. See it? How they just blew up on that boundary? So that robbed the front from getting good blow up. So all we were able to squeeze out is just a couple of storms until you get further north. So it means the south side got hit the hardest, and of course there's all the lightning associated with these and the colored deals that you see. All right, let's see. What else do I want? They didn't turn that on. All right, let me do this. And then we'll go back to radar. So, for a potential tornado parameter value, I like to look at this thing and, where'd it go? Put that back up here. All right, so on the STP 1.7, can this get any bigger? Yeah, a little bit, so you guys can read this. So the STP value, we are in the middle of the threshold, so we've got that going for us. A significant tornado parameter, by the way. Supercell, composite, are right in the middle as well. The Cape, we have more than sufficient. Shear, we're a little on the low side, but still within the margin. Effective helicity, we're on an outlier. So we're lacking a little bit of helicity. And then the lifting condensation level down below 1,000 meters, so right in the middle of that. So what this tells you is that the atmosphere is conducive, if things would go just right, for a tornado. Now, I've used this every severe weather event, and you've seen me use it if you follow me. And this is our latest, tech that we've used to work with on this kind of a nowcasting event. And sometimes it does all right, and other times it's like out to lunch. It's so hard to get tornadoes. It really is. You guys have no idea. And that is a really good thing, even in Oklahoma. Let's see, anything else I want to look at? Ooh, I wonder if they're running. Oh, let's take a look. Okay, it is. No, it's not. It's old. Okay, what about this guy? Yes, that is running. Good. All right, this is the research radar down in Norman. My stream's kind of dropping out a little bit. So if it freezes up or something, you'll know why. Okay. Anyway, I'm always looking at whatever data I can get my hands on. So, research radars down in Norman, I'll take them anytime, any day of the week to get another view of storm structure that's different from other views. So there you go. Okay, so let's go back to my guy here. Still got some big hail up here near Ralston and north of Blackburn. So that is a good old-fashioned hailstorm. Otherwise, some general thunderstorm activity here around Stillwater. So that one heading toward you is really weakened. That's good news for you. The one out here in El Reno, there's a little one there, but no big deal. The one here south side Oklahoma City, no big deal. And then we got the one down here in Noble, and that thing's falling apart. It just can't get its act together. Never could. Time is at 6:30. What's our temperatures down here? 84 over 75. 87. Yeah, see, we were 10 degrees warmer. Be a different story. That's good, though. A lot of inch to inch and a half reports. Looks like some flooding here in Norman, typical. About a foot of water over Boyd and Berry. Let's see here. Yep, inch and a quarter, inch. Okay, so there you go. So that's what's happening southeast of town. All right, well, let me look at the something else here that is of interest, because I'm losing interest. Man, these winds over here stand a little corrected. That northern end of the decaying part of this, the other storm that's north of the one that's south of Norman. So in other words, we're north of Norman and southeast of Moore. We're on Franklin Road and Porter, and those winds are at 55 to almost 60 miles per hour in this little area of blue. And then west of the radar, they're about 51, 50. So still a little bit of some straight line winds here coming up on 77, running right down Franklin Road. All right, let's see what else. Nope. Man, did I get any rain? Yeah, I did. A quarter of an inch on that deal. But let me check my Tempest. So I have a new weather station that I bought a couple months ago. I've been testing it out. It's called a Tempest. And there's a blog on my website. You can see aarontuttle.weather.com. If you have my weather app, just click in the blog, and you can read all about it. I posted about it, and in there I give you just a coupon code. You can get 10% off. So it's cheaper than the one I normally recommend, which is the Davis, because it's like the top of the line. It's the real scientific, nerdy one, but it's expensive, so I get it. That's on my Amazon affiliate link with a little bit of a discount on that one, but it's still expensive. So this one, I thought it's a whole new radical design, right? And I'm thinking, okay. So me and a couple of guys at work went in and we each got one to test it against real live conditions here to see how it did, and it did awesome. So I was like, okay, I feel comfortable recommending it. So now I recommend it to get as a weather station, because a lot of you always ask me what's the best weather station, and now I can actually say that, and one, you can actually afford it. It's still expensive, but not nearly. I mean, it's not an arm and a leg like the Davis is. This one is more feasible, and it's really easy to set up. And you get paid. The company will pay you for sending the data. I'm just like, what? What a deal! Sign me up. Okay, so but that's on my blog at aarontuttle.com. So I got 0.36 inches of rain from this guy. So there you go. And it even tells you like when there's lightning in the area. And I'm looking at my phone because it's app driven, and then I can also pull it up on a browser, so you get your own web page for it. I could have just done that. Well, I didn't think of that. Squirrel. Oh goodness. All right. I think I'm about to let this one go, guys. This one over here is just, it's not doing much. It's kind of slowly dying. You'll probably still get some gusty winds out of it for a little while, and the hail sides really haven't been all that great. About an inch to inch and a half, so nothing dramatic like we had before. So there's something going on different. Oh, that's what I was going to do. I pulled this up for some reason. I forgot. I got sidetracked again. Okay, I was going to look at the wind shear. The wind shear is actually weaker in the mid-levels of the atmosphere. Stronger in the upper levels, but weaker in the mid-levels. And it's a little chaotic only because that first storm went through. But I don't know. It's still not bad for summer, but we're just not. There's something else missing. Cap could be building in. So because we didn't get hot enough, that's probably what it is. Because we were supposed to be, like I said, mid-90s, and we're low 80s. So the cap will build in at low 80s and kill these storms. So that's probably what's going on. So plus we're getting late. It gets dark earlier. So yeah, that's what's happening. I knew there was something. All right, so look, that's it. I hope you guys enjoyed the severe weather coverage. I wasn't expecting to try to do tornado coverage at the end of August, but we did it. So stranger things have happened. Now we do have a mini severe weather season in the fall. Usually that does not start now. It usually starts at the end of September. So it's usually kind of a October period, plus or minus a week, like the last week of September, first week of February, something like that. February, first week of November, something like that. And so usually I have about 6 weeks there of potential severe weather, and it's a little bit different. Sometimes you get tornadoes in a kind of a northwest flow that come in. Faster moving cold fronts though, so it's not as ideal as it is during the springtime. A lot of times these fronts kind of clear things out too much moisture wise, and we get some really great temperatures. Actually my favorite time of the year here. I love the fall. I used to love the spring until I got older. I was like, screw this. I'm tired of all these tornadoes. And so now I love the fall. I'm a changed man. So anyway. All right, listen, thanks again for watching, telling your friends and family about all the coverage. Appreciate you guys on YouTube. Follow me. And doing the informal greeting, did it again. He tipped me. So I appreciate you, buddy. So he drops the old super chat YouTube tipping deal, which is really cool. So it's a good way to get back to your creators. So he does that, and then several times, man. Oh yeah, and then I've got Patreon, I've got Subscribestar, I've got Facebook fan subscriptions, I've got YouTube memberships. So there's all kinds of ways you can donate or give back or tip in that fashion. So if you'd like to, just for what I do for you, it helps me to cover all this stuff, including my time and resources and data feeds and everything else. So, but I appreciate you guys' comments on here. I'll go back and look at some of them when I wrap up here, see if there's anything of importance that I missed. I'm looking at some of you guys on YouTube now, reading your comments. That's funny. Yeah, I see some of the comments about the local news. So that's another big difference. You will see just a different way of covering this kind of stuff. So it's hopefully a welcome change. All right, I gotta get out of here, but I appreciate you guys watching. If something were to change, I'll let you know. But I think we're good. All right, take care, everybody.